Hello, my name is Austin Johns, and today I'm going to give a brief overview of literate programming and two of the options available for engaging with this programming paradigm. Literate programming is a programming paradigm which documents a computer program using natural language with formatted text and interactive code snippets. Literate programming presents an alternative to extensive traditional commenting. The use of natural language and interactive code elements makes it particularly useful when communicating computational thinking in an educational setting. A markup language is used to format the text blocks, and a programming language is used to execute the code blocks. The first image on this slide shows the markdown source code on the left and the rendered text on the right. The second image shows a block of rendered text and a code block that has been executed using the Python script. This slide also contains a link to the Wikipedia article on literate programming for further study. MATLAB is a popular programming language in STEM research, and the MATLAB Live Editor is a tool that allows for the creation of MATLAB Live scripts. MATLAB Live scripts, identified by the .mlx file extension, can be created in both a local copy of MATLAB and MATLAB Online. MATLAB Live scripts are notebooks that combine formatted text and computational code in a single publishable file. In a MATLAB Live script, a simplified version of Markdown and LaTeX are used to format text. MATLAB code is executed in coding cells. The first two images show the complex equations that could be rendered using LaTeX, and includes an example of the integrated nature of text and code blocks in a MATLAB Live script. It is important to note that on the top right-hand side of the Live Editor, code outputs can be rendered to either the right or in line with the MATLAB Live script. Code can also be hidden entirely. This is particularly important to know when viewing shared MATLAB Live scripts, as code may be hidden by default if the creator planned to center focus on included interactive elements. MATLAB code also requires that functions are defined at the end of the document, which is a common source of confusion for individuals with experience with other prominent programming languages such as Python. One of the notable benefits of MATLAB Live scripts over other examples of literate programming and simple MATLAB scripts is the ability to easily add interactive elements to the live script. These interactive elements, when combined with the natural language focus of literate programming, better allow students to digest the underlying logic behind included STEM topics and computer code. Jupyter Notebooks are a popular free and open source alternative to MATLAB Live scripts. Jupyter Notebooks, identified by the .ipynb file extension, can be created online via Google Colab and locally via a standalone client. By default, Jupyter Notebooks use Markdown and LaTeX to format text cells and Python to execute code cells. However, more than 40 programming languages are supported. Python, unlike MATLAB, requires functions to be run before they are called. Thus, functions should be placed earlier in a Jupyter Notebook instead of at the end. Jupyter Notebooks also render directly on GitHub, which is a very useful feature considering the seeming ubiquity of GitHub in STEM research. The images on the right depict a portion of a Jupyter Notebook, Markdown and LaTeX source code, and the rendered result, and an example of Jupyter Notebook rendering in GitHub. That is all I have for my presentation. Thank you for your attention.